Hello everyone, in this video tutorial I will show you how you can build a simple image classification model and also how to use that image classification model in your local computer. So as you can see, this is my local computer, this is Windows computer, and I have opened a Python file here, and this is just few lines of codes, and using these few codes I can classify whether these images are image of cat or dog. So if you want to try your own model and your own images, then you have to change only these 3 lines, and then you can use this code, because in this code you don't have to modify anything else of these 3. So the first one is the file, which file you want to choose. So here I is using this cat image file, so you need to provide the full path or the relative path. So it's since the Python file and these image files are on the same folder, so I can give directly this way, and this list contain the labels, I mean the classes of images, so cats and dog in this case. And this third one is the model path. Where is our model? The saved model, it's here. So that's all. So when you are going to use your own classification model, then you just have to replace these 3 things, and you can use this rest of code as it is. So now we have this, so let's run this code and see the result. So it says this is a cat, and that is because the 1.jpg is a cat. Now try with the 2.jpg, and let's see what it says. So it says this is a dog. So you can see this is like a magic. So if you want to learn how to do it, I'm going to show you in this video how you can build your own image classification model. So I'm going to do it in Google Colab, so you don't need to have any kind of GPU to train these models. So let's get started how to build your own image classification model. So of course, at very first you need to have image data. In this case I have images of cats and dogs. Now the cat images and the dog images are in 2 separate folders, and those 2 separate folders are in a different folder. So I have that zip file in my Google Drive, and that's what I'm going to download it using zdown command and the link here. So once this download, then we are going to unzip it and then remove the zip file. So let's run this cell. So as it's running, let's explain this. Here we just have some important libraries. Simply copy paste these libraries, and that's gonna work. So in this downloaded data we may have some corrupted files, corrupted image files and non-usable image files, so we need to clean up that data. So this simple block of code, that simple Python code, that will do the job. So you can see here it's removing any grayscale images, because the number of channel in grayscale images is 1, but our model expects RGB image, which means 3 channel image, so we are going to remove those. And also removing which is not an image file, like any other file like txt files. So this way we can clean this. So once we have cleaned up data, first run this cell also to import it, and here, so the above cell runs, and we have already downloaded, unzipped and also removed the zip file. So let's see what we have now. So we have the pad images. Inside the pad images we have cat and dog. So in the cat folder we have cat images, in the dog folder we have dog images. So remember this folder name, which is pad images, because we need it later on. So let's see it now. Here we are defining transform. Now it is going to take image and it's going to resize into 255 pixel in both direction, which is height and width, and then going to center crop by 224 pixels in both direction, and then it's going to transform into tensor, and then going to normalize those image datas, image pixel values. So now the pad images is the folder name that we have here, and inside that folder we have cat and dog images. But if you are using different set of images, like different types of butterflies or different breeds of dogs, then all of those will be in these different folders, and this folder name should be in here. So this dataset is from Torch Vision, and then using this datasets image folder and the path where those folders are located, we can access those images. So now applying this transform to transform that image. So once we have that, this dataset, we can get the length, how many total images we have now that is saved in this variable. Total images, the images of cat and images of dog. In total we have this value is in this variable, so length of dataset. Now from the total images that we have here, the variable, we subtract 6,000, and it is this 6,000 images we are going to use for test. So we are going to use that 6,000 images for testing purpose. So we define two variables: the number of images we are going to use in training set and number of images we are going to in test set. Okay, and now in the train set and the test set we are going to split it. So you can split this way. We're passing that dataset from here, and in a list we are passing the integer values from here and here for the train and test, and that would be split into train and test this way. Also defining the batch size. Now here we have train set and test set. So data loader dataset is the train set, and tuple is true, batch size is the batch size, and the same way we define this in the test set. Now here for the device, if we have device CUDA enabled, then we are going to use CUDA, otherwise use the CPU. That's what it's saying here. And let's print that whatever we are going to use. So run this cell, and it says we are going to use, we have enabled CUDA, so we are going to use CUDA. So let's see what we done this far. First, we downloaded data, extracted this data, and we deleted that zip file, and then we imported all the necessary libraries, and then we cleaned up data, and here we defined transform object, and that transform is passed here to apply transformation to those images. So here we have defined this dataset variables from those all of our images after applying the transform. So here we have splitted data into train set and test set, and then created variables, train set and the test set data loaders, and we also defines device. So once we done that, so now we need to create or define model for our image classification. So here you can use either of these two block of codes, but I'm going to use this ResNet, but you can use this VGG16. This would be almost same as this one, so I'm going to explain this. Here what I done is I just downloaded pre-trained ResNet 50 model, and then from the Torch Vision models I get this model architecture, and then loaded that ResNet model that I just downloaded using this, and that's it here. And now freeze all those layers because it is transfer learning and we want to train only the last AppC layer and not other layers. So from the param recurse grade is false, so sets all of those into false, only the last AppC layer from the model. So we change that into this. When we change this, it automatically sets recurse grade into true. But if that's not the case, if you think, then you can use this line of code to make it recurse grade true. So anyway, here the out feature is 2 because we are going to use only 2 class in this example, that is cat and dog. But if you use different sets of classes, the number of class you have, you need to define it in here, and other than that everything is same. So we have done this block of code, and if you see this, it's almost the same. Anyway, now we need to define optimizer and a criterion, which is a loss function, and this is a classification problem, so we're using a cross entropy loss function, and we are using Adam optimizer. When you don't know which optimizer to use, then you can simply use Adam optimizer because it's general purpose optimizer, you can use it. And this block of code is just to train our model, and here you can see first we just bring that model into training mode, and we set epoch 3. Here initialize some variables to calculate total number of correct and running loss, and we just loop through our train set and got this input and the labels. We bring those into device. If it's CUDA, then it will bring from CPU to those device, otherwise this line have no effect on CPU. And now on the model that we had earlier, we pass our inputs, we got output, and then we're getting the output index using the argmax, and now the total correct can be calculated using this labels equals output index, which means labels carries which index is correct, and here this argmax output and dimension 1, it will return the index number that is predicted by our model. So this way we can calculate number of correct output our model have calculated. We just sum it up and we're getting from tensor to integer normal number. And now here we are zeroing out the gradients calculated in earlier loop, and if it was calculated, then it will bring it into 0 grade. And now calculate the loss using the criterion, pass the output and the labels. Now the running loss is calculated. This is just keeping note the running loss, and then that loss is applied a back propagation using the loss dot backward. Now optimizer dot step, it will update the weights to improve our model to predict better in next time. So when everything done, in each epoch it will print out the running loss and the accuracy. So when all these 3 epoch is done, it will say training is finished. So I didn't run these cells, I just explained. So let's run it. And this block will take time to train complete. And when the training is done, we can test it. Now testing is almost same as training, but we are not using any kind of loss function or optimizer. We are just doing it some portion of training code. We bring it into test code to test the data. And if you understand the training part, you can read it and understand it yourself. And that's pretty self-explanatory, as it is almost similar with the training. I'm not going to explain this in here. So once training and testing done, I'm going to save this model using torch.save model state date, and this will save into this file name, cat versus dog.pt. So we have to wait. I guess I got some error. Actually, this error is because I didn't run this clean data cleaning part. So we need to clean our data, otherwise we will get error. So now run this, and we already run this, so now we should not get any error. So that's why this data cleaning part is very important. So we have to wait, and it will automatically save it. Once this is saved, we will download this model file, and then we can use into our local computer, as I already shown you earlier at the first starting of this video. So that code that I shown you on my desktop is this is the code I pasted in this block, but I need to upload 1.jpg here, so I'm just going to upload it. So this image uploaded, and now run this cell as well. So all we have to do wait, but I'm going to do fast forward this video so you don't have to wait, and we can directly see the result here. So now training part is finished. As you can see, in the first epoch it got 97% accuracy, in the second it got 98, in the third it got 98. So 98% accuracy we got in 3 epoch, and that's a great result. And now we are testing it in our test data. So we got 98.3 accuracy, which is we don't have any overfitting problem in this model, so that's great. And it saved the model in cat versus dog.pt. It is here. Now you can download it, click on download and it will download it. Since I already have downloaded, so I just cancel this, but you need to download it to use it on your local computer. So I will show you, instead of local computer, you can also test it on Colab directly here. So I uploaded 1.jpg, this image, from my computer to here, and I have a cat image. Now run this cell. I already run this actually, and this result as this is a cat, which is correct. So you see, training a image classification model is not that difficult, and this is done. We are done classifying our own custom model, and this training part took about 6 minutes to complete these 3 epochs. So here, once you downloaded this model, you put it on your folder, and you should have this Python file, and then you can run as I did earlier. Here you can try with different images like the 6. I didn't try that earlier, so let's do it here and run it. And it says this is a dog, which means it's right, and try it with the 7. This should be result a cat. So this is the image. This is very small image, you can see, and it says it's a cat, so that's great. Let's see this image size. This is 300 by 168 size. Anyway, we got a custom image classification model in just about 15 minutes. So you can try your own, and if you need these codes and files, you can get the link in the video description below. Please support my channel so I can make more interesting videos like this. Thank you for watching.